All right, so I finished USACO I think like 2 hours ago, and I'm gonna give solutions for problems one and three. So I was able to get the whole problem here, and then I was able to get half of three. I could have gotten full of three, to be honest. Um, the reason why I didn't decide to code the faster solution, or I tried it, but then I was like not, I was getting wrong answer for these cases. I have no idea why, but um, I decided midway of finding the fast solution of coding it. I was like, you know what? I'm just gonna go to problem two, and I'm gonna just like because half of a problem is good enough if you full solve the other one since I already got the first one. But I went to problem two, and problem two was bad. I got cooked. I think this is like the hardest question of the contest. I low-key think I'm misinterpreting the problem, or my solution is just completely wrong. Because I low-key thought that my code could work, but it didn't. So let's first start off with the solution for number one, though. I can definitely explain this one. And I recommend you solve this problem because when I read this problem and I was coding it, this immediately reminded me of this problem that I solved actually, like, not even less than a month ago. So it's kind of cool. This was like a 1600. And if you look up my solution here, right, like, you notice that, like, I'm using a priority queue and I have this lambda in here and then I have like an array and I'm like doing comparisons. It literally looks very, very similar to this. Like very, 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 very similar. I have like a priority queue with lambdas. And the only reason that it looks like more cluttered is because I have like this little detail that I had to add. But that's pretty much what it is. And Usico apparently doesn't like it's space sensitive, which means that like if you add an additional space where it's not supposed to be, um, you're gonna be cooked. So I had to do that's why I had two submissions because the first submission I didn't consider spaces at all, but you have to do that. It's really not that big of a deal. But this problem, I recommend you solve this problem and see if you can solve this question. They're not exactly the same problem, or are they? I don't even know. All I know is that they use two of very similar mindsets. And so, because I was able to solve this problem in practice, I was like, this question took me like no more than 20 minutes. It was a pretty easy question, for me because I had like experience of these types of problems, which is honestly how people like solve problems is because they have experience of previous problems. So for this problem, we basically have this array. So we have an array as like 98% of problems have arrays, no? Three, two, one, two. And the idea is that like you can perform this operation where you can choose some element and insert it anywhere to the left of the where the element already exists. So I can basically choose this element and then just choose to shift it over however many elements I want to the left of it. So maybe I want to insert this element or shift it over all the way over here, going past 321, and I can perform that operation at most once. And the idea is that after iterating through B in order, I want to and choosing whether to append that element to the back of B or not, um, what is the what is the what is the lexicographically greatest sequence that I can achieve for B? And so the first thing is just to solve this problem, assuming that you had no operation. And if you solve this problem, assuming that you had no operation, the solution is very straightforward. It's just create the largest leftmost element. So I'm curious on what's the largest leftmost element. It's four. What's the largest leftmost element? It's three. What's the largest leftmost element? It's two. What's the largest leftmost element? It's two. Then the problem now, oh, this should be three actually. My bad. Whoops. You could technically just actually it doesn't really matter if I use two. Yeah. The problem now is that if I create the largest leftmost element, it's going to be one. So the index here, I'm going to one index. So the index here, this is index four, and this is index five. So this is index five. When I create the largest element, I can't actually have one because this index, and this is literally the same exact idea that you actually use here. That's why this question was eerily familiar. This index here that I have, that index is smaller than the previous one, which is bad. Because what it says is that anytime when I carry the largest leftmost element, I'm basically, so for example, let's say I have some elements here, and I carry an element there. I'm basically saying that all these elements, I don't care about you anymore. I can't access you anymore because my assumption is that I didn't append A and B to the back of B, and I've already went through them. So, or A and B to the back of the array that I'm going to create to my sequence. And so that's basically what it is. So because this element has an index smaller than the previous one, then obviously it's bad, and so you can't print it out. So this is where you can use the operation at least once to improve your answer. You can be like, okay, well, for this element that's at 1, what I can do is I can just say, let me append this 2 in front of that 1. Let me move this 2 in front of that 1. So that way, when I carry this, we'll have 4, and then this will have 5, and then I can have the entire sequence as 4, 3, 2, 2, 2, 1. So that's basically what it is. So really, like, and this like entire solution, because my I had a wrong mindset like this. So the reason why this question could be hard is because you might be asking yourself, okay, which element should I so you might be saying, okay, well, which element should I move and how far to the left? And the question is, just looking at it, you don't know until you actually get there. For example, when I got to the fact that this element was like 5 and this was 4, I didn't know that I should have moved um, this 2 to the front of 1 until I actually got there. Like until I actually got there. And this is like a similar like theme here, right? Like don't worry about the issue until you actually need to worry about the issue, right? For now, you can just print out 4, 3, 2, and then when you actually need to worry about it, you do. And so that's basically the solution here. So I'll show you my code. Basically, what I do is I have a priority queue of pairs, and I'm going to sort them by their by greatest value. But if there are ties between these values, so the first element in the pair or the array, I use array as pairs analogously the same thing. Um, then if they have the same value, sort them by index by I believe, yeah, ascending index. Otherwise, sort them by value. And the idea is that I just want to be able to carry the largest leftmost element. And the idea here is that what I'm going to do is the case is easy, right? If the current index is actually greater than the previous index, I can just like print out the current value. Like that's good. The problem is when I'm trying to print out an element that actually has in which its index is less than the previous one. So the previous one exists here, and I'm trying to print out something that I said I would skip over, that I would completely not append back to the end of it. So then the intuition here is that okay, well I really want to print out previous because I'm interested in the lexicographically largest sequence of B, and so previous is currently by the definition of a priority queue my best element that I carry because you always my priority queue is basically a structure that allows you to carry the best element possible, the element with the highest priority, and so I'd really like to print that element out, but there's an issue, right? This element occurs, the element that I want a runt occurs behind me. So the only way to fix that is obviously to move previous in front of current, right? But if I move previous in front of current, right? Let's say this is the current. Let's say this was like previous one. Previous uh uh the other previouss. So let's say this is like previous k actually, the kth previous. The other previouss like k minus one, um k minus 2, etc., they all have to be behind the current element. Because what I'm going to do is I'm going to move the kth previous back, and so that way I can print out this current element. But the assumption is that like if you do this, which you non-negotiably need to in order to print out the current element, these also have to be behind the current element. And so what you can do is you can just like, keep track of your sequences of previous's keep track of your sequences of previous's, and really you just have to keep track of like the last two previous's. But because I didn't really want to keep track of the last two previous's, I just added like okay, I have it here. Um, I just added like it into an array, and Basically, I just checked. Okay, are the last two previous's less than current of one, because I know that I'm going to like move this here, so that's going to be less than current, so that's fine. But I have to check, is the second to last previous less than the current element, and if it is, then I can print out that element, and I've already used my freebie, I've already used my operation, so then I set it to true, and I set the previous, to the current element, to the index of the current element, and then I just go. So that's really the solution. So pretty good problem. I like it. I do have experience with, I've seen those similar ideas before. So, yeah, this was a pretty good problem for me. Um, but yeah, again, I would just say for this problem, it's more so like when you have these because I've seen these problems before. When you have these lexicographically greatest or lexicographically smallest, your mindset should be like, I only care about the best element right now. Every other element does not matter. I don't care if I can't print the second largest element. I want to print out the largest element. So your eyes should be gravitated towards those elements that are the best. And then, you know, if you can't print it out, then you're like, okay, well then let me use my operation and make sure that I can print it out. Because the idea is that like the reason, so I can prove why you use the, let's say you don't use the operation when the first time it occurs that the previous um uh is to the right of current. Let's say you don't use it. Then the idea is that if you don't use it, you're going to obviously have a worse answer. You're objectively going to have a worse answer. Uh, because if you don't, then you're going to be like, okay, well, I can't print out current. And so then I'll go to the next thing. And if its value is smaller, then I'm going to have like a smaller element here. I mean, I could have had a bigger element here. Let's say this is my sequence. And so obviously that's bad. And even if it's not smaller, well, the idea is that like, okay, if they're the same value, then lexicographically they're currently the same thing, but it's worse because now you just chopped off more elements. And so you have access to less elements where you could have just been here and have access to more elements over here and then still continue with the problem. So it's pretty obvious if you think about it like that. All right. So the third problem, this question, so I'm not going to talk about the fast solution. I'll just talk about the general solution. To be honest, like I'll leave the fast solution as an exercise for both anybody watching this. Like I think you should code it because I did try to code the fast solution right after I got knew that my logic was correct. And for me, I mean, I guess I set up implementation. It didn't work. Maybe I did some dumb thing. But here's like you have like two numbers A and B, and you want to basically transform them to C and D. And the idea is that like you can either from A to B, you can go from A to A plus B, or you can go to A or sorry, yeah, A plus B, or you can go A to or sorry, A plus B A. Yeah, you can you either increase the first element by the size of the other one, or the second element by the size of the other one, or the first element by the size of the other one. And so you have two options. And so, okay, so honestly, my first thought was just saying, okay, well, um, right now it's not clear to go. Like if I go forwards, I don't know if I should. Like I have two choices, right? I can either transition to this or that. I have absolutely no clue what to do. So I was like, okay, I've seen these types of problems before. Um, let's just go backwards. That was my intuition. That was genuinely my intuition. Like I just was able to skip that thought process of motivating why to go backwards and just go. Let's just go backwards because the idea is that in these problems you don't have to just go forwards. You can also start from the like you. It's just this is a general problem, right? Where you have you have a state and you're trying to go from the initial state to a final state. Instead, you can just think of like going from the final state to the initial state, and that might be easier. And in the case of this problem, it precisely is. Like, for example, let's say I start with C and D. then the idea is that if I start from C and D, like either it has to be C, C minus D, or D minus C, or it had to come from uh, C minus D D, right? Or it had to come from this. It goes from here, or it goes from here. And the idea is that one of these things have to be negative. Like if you take the or non-negative, like definitely just one of these things are not going to be positive. And remember, in the state, because all these pairs are positive numbers, if you have a non-positive number, my bad. If you have a non-positive number, that means that you that's impossible. And so because one of these elements are gonna if you take the difference of two numbers, obviously you're going to have a non-positive number. Like if you take the difference of two numbers from like x minus y or y minus x, obviously one of these numbers is going to be non-positive. So for example, let's say I have 10 7. We take the difference there and take the difference there. Obviously, one of them is going to be non-positive. And so the idea is that when you go backwards and you actually look at it like in that lens, you objectively know that one of these pairs is absolutely invalid. Which means instead of having two choices, you only have one choice, and you basically just have you basically can just find your sequence of transitions to get to your initial state. And so that's basically what I coded. I basically was like, okay, well, if C is greater than D, then obviously I know that C, the previous was C minus D, because I can only deal with non-positive numbers. Otherwise, it's going to be D minus C, and I just count it. And if they ever match, I break it. And obviously, if any of these are non-positive, then I get out of there. And so that's the solution. So this is obviously too slow. And so what I was thinking when I was doing this problem was I was doing some like um, optimization with modulo, because obviously you can just like think about it. All you're doing is that you can keep subtracting like d until this number like goes below goes below d. Like you can keep subtracting those multiples of d because you're just gonna keep subtracting them. Basically what you do is you just go like CD, and then you this is it smells very familiar to Euclidean algorithm where you do like C mod A and like all that stuff, or A mod B, or GCD of A B is equal to GCD of A B mod A. This smells very familiar. The only problem is I have no idea why my code didn't like work. So I won't really talk about it here. But basically, I was just trying to like use some modulos to speed them up to subtract like the multiples really quickly. So yeah, I mean, I know if I spent like the remaining time on the problem, I would definitely be able to like figure out how to, because the optimization is just saying instead of doing C minus D, you do C minus DK, where K is some number that reduces C as much as it can be until you like go beneath D. But like I was just trolling something, I think. Some like detail that's really not like the main chunk of this problem is just to notice that you go backwards. And once you notice you go backwards, it's not too hard. Like you can get like half the problem actually. So yeah, that's the solution for this. For two, I'm not particularly sure. So my solution was, I know that like okay, so you want to find like the length of each number. And the length of each number is pretty easy. You can just do like a very, very, very small BFS where the length of some node is equal to the length of its parent plus one. And the way you do that is just by making like a graph, a directed graph, and then just BFSing through that directed graph. And then at each child, you can get beat. Because the idea is that like the node you remove, its length is already figured out. So you can use that node um, and find it. It's pretty simple. But then I thought like I don't know why this is wrong. Like I got it wrong. I have no idea why. Everything's wrong. Because I thought like um yeah after that like I just my logic at least was like okay, well um if I have like these words, right, let's say I have like the fifth word is uses like the second prefix. The third word uses a second prefix. The fourth word uses a second prefix. Where the fifth word is the second prefix, but the second prefix, but just some additional character attached to it. I thought that like for this one, like you basically have to print out the entire word. You have to print out the entire word. But for this one, you just have to print out the prefix because um, you don't have to print out the entire word. You don't have to print out the additional character, just because like you've because these guys have already been read, so you know that like there's only one such word remaining that uses a second um, prefix, and then therefore you only have to print out this. But I think I'm not considering something. I really hope it's something like massive, because if it's something that I can easily just consider, then well, GG's. You could have easily promoted, but yeah, those are the well, that's my contest overview, honestly, of this contest. So yeah.